did you have for yesterday's? Oh, yeah. Number 7. So number 7 is, this is power rule. Power rule means I'm going to multiply exponents. Product rule, add exponents. Anytime you have parentheses, you're raising this to a power. So I'm going to put a 1 here because this 4 did not have an exponent, correct? And you need to multiply 4 times 1 and 4 times -1. So what's 4 times 1? 4. And what's 4 times -1? -4. Now, I heard someone say 256, which is correct. When I take 4 times 4 times 4 times 4, that is 256. And that's a positive exponent, correct? But this one's negative exponent. What does negative exponent mean? Is it going to be on the top or on the bottom of a fraction? It has to go to the bottom. If you put a line under this, like making a fraction, this one would have to go to the bottom. The 256 will stay up on top. So it'll be 256 because 4 times 4 times 4 times 4, 4 of these is equal to 256, right? And then underneath here, I'm going to have x to the 4th power. Does that make sense? Okay. Any others? Did anybody want to check any of the other odd ones? Oh, those were the bonus. I'll do it, but remember, this one is only for the brave. Okay, these are like the bonus problems, but I'll go ahead and do it. Down here, I have a combination of product and power rule. Do you all agree with that? And this numerator is already simplified. So over here, I am going to put 1 as the exponent for that 2. And I have to multiply 3 times 1, 3 times -4, 3 times -2. So 2 to the 3rd, right? And then what's 3 times -4? -12. And n 3 times n to the -2, -6. And then over here I have 2 to the -3, and I have m to the -12 again, n to the -12 again. And then over here I don't have power rule. I just have 2 m to the 3rd, n to the -1. Okay, when I do these, I try to simplify all this yucky stuff first to combine it, and then I'm going to move my negative exponents, okay? So, 2 to the 3rd and 2 to the -3rd, these have the same bases. If I add those exponents, isn't that 0? So that's just 1. So these cancel to 1. So I don't have to worry about those. Now, m to the -12, m to the -12, m to the 3rd power. Well, what is, I'm trying to find room up here, -12 plus -12 plus 3. Well, this would be -24 plus 3 would be what? -21. So the m would be -21. And I'm just going to cross these out because I dealt with the m's because my eyes are bad. And I want to make sure I don't lose anything. I have a 2 here. These 2's are gone, so I'm just going to put a 2 in the front. Is that okay? So then I could do this. Now I'm going to do the ends. I have 3 of them. I have 1 to the negative 6, and then I have to the negative 12, and then negative 1. And you add all those exponents because they're all ends. So what's negative 6 plus negative 12? And then plus negative 1, negative 19. And so then that'd be n to the negative 19. So right now, this is what I'm looking at. M over 2, 2m to the negative 21, n to the negative 19. I can't write, when I'm simplifying, I have to have positive exponents, correct? So this 2 stays down, right? Because there's no negative exponent. But this has a negative exponent. Negative exponents in a fraction is like saying an elevator button. If it's on the bottom, I'm going to bring it up. If it was on the top, I would bring it down. Because a negative exponent means inverse of, right? I'm going to end up having to combine, correct? So this comes up and this comes up, but the 2 stays on the bottom. So I have m squared, because that one was already up there, but I'm also going to move m to the 21, not 12, 21, n to the 19, and then the 2's left down below. And now I'm going to combine the m's. What's 2 plus 21? So it'd be m to the 23, n to the 19, all over 2. Was anybody able to get that one? Because remember, these were the hard ones that were bonus. You didn't have to do these. Teresa, you were able to get that? You should pat yourself on the back. These weren't easy. Okay, so we understand that? We good? You were confused. Did you figure it out? You good now? Yeah. So I may have one of these as bonus on the test, but that's bonus. So if you don't get it, it's no big deal. You have to be able to do these here, right? These up here is what you should be able to do. So let's look at the do now right now. Is this the do now? Yeah, now this is what you have, right? File, print to PDF. Okay. Save. Yes. Downloads. Okay, here I am. Let me make this bigger for the people in back. Okay, so our first day of class is what we did for 1 through 4, right? Everybody agree with that? So, square root of 27. You need to have the factor chart out. Make sure you have this. If you need another one, I think I have some extras up there. You look at number 27 on the list. I have 1 and 27, 3 and 9. I'm just going to write it right here. 1, it'd be nice if I wrote 1 and 27 and 3 and 9. We want to look for the combinations that have a perfect square, right? Which of those two numbers is a perfect square? That if I take the square root, I get a whole number. 3 and 9, because 9 is the perfect square. So I'm going to put square root 3 times 9. But this one gets to come outside, right? This one comes out to play because it's a perfect square. This poor guy has to stay at home. Okay. What's the square root of 9? 3 comes out. The other 3 stays behind. Right? Okay, now let's look at 80 on our list. I know 4 goes into 80, but is 4 the largest perfect square on the list? Because there's a lot of numbers here. 5 and 16, because 16 is a perfect square. So I'm going to look here, and I'm going to say, oh, 5 times 16. And what is the square root of 16? 4. So this would be 4, because it comes out as a 4. And then what's left behind? 5. Make sense or doesn't make sense? Did that make sense, boy? You good? Okay. Anybody have a question on this one before we move on? This is your lifesaver right here. If you learn how to use this chart, you're in good shape. Okay. Yeah. Okay, so my uncle made me memorize when I was little. I mean, I'd be in the car with my brother and I need to make it a competition. My poor brother was 3 years younger than I am, so it really wasn't fair. So, he'd say, "Okay, 2. What's 2 times 2?" And I'd go 4, and then he'd go, "Oh, good." And then he'd go, "What's 3 times 3?" And then I'd go 9, and he'd go, "Yes." Do that with your kids, all of you. You have kids in the car, turn off those darn devices. Teach them their multiplication facts. That is a gift that they will have the rest of their life. Those stupid cartoons or YouTube videos, that means nothing. Teach them their multiplication facts in the car.
That seems like such a positive memory for you too.
Yes.
I'm gonna start doing that to my sister's kids.
Exactly. I know, and I still remember, and he probably doesn't even remember he did that, right? And how much has affected me to become a good math teacher. Okay, now look at the number 50 on your list. What is the perfect square on that list? 2 and 25. Do I care about 5 and 10? No, because it's not a perfect square. 25 is the perfect square. Because what is it? 2, not 2 and 10, 5 and 10. No wonder you looked at me funny. 2 times 25, right? And I still have this x to the 4th power. So, what is the square root of 25? 5. And then the 2 stays behind, and I still have this x to the 4th. Now I'm going to ask you a question. And I'll act like my uncle. What's x times x? X squared. What is x squared times x squared? X to the 4th. So what would be the square root of x to the 4th if x squared times x squared is equal to x to the 4th? X squared. So this comes out as x to the 2nd power, x squared. So it should be 5x squared, square root 2, yay. We good? Okay, now 8. Look at your perfect squares for 8. What pairs, when I multiply them together, has a perfect square? Yep, 4 and 2, or 2 and 4, whichever way you want to write it, because it means the same thing. I'm going to take the square root of 4, which is 2. I have an m here, I dropped. Square root 2 is left over, and m is left over, because m, there is no other you can't take the square root of m, because it's just m, right? There's nothing I'm going to multiply by itself to get m. Okay, we good with those? I know the variables were getting people for a while. I think by now I'm hoping we ironed that out.
I feel more confident in the top end of what we just did.
Yay! Okay, so over here, I have negative, that's like a -1 in front, times a -2. What's -1 times -2? 2. I have x squared times x. Remember, there's an invisible 1 for that exponent there. It's an exponent of 1. And you add your exponents when you're multiplying. You multiply coefficients, you add exponents. What's 2 plus 1? 3. So that'd be x to the third power of 3. Now, y to the fourth times y to the second is y to the sixth. That's it. For these type, for 5, 6, 7, that's called the product rule. Product rule. You add exponents, right? This is simplifying radicals. They're not exponent rules. Yeah. Okay, so let's do this one. The coefficient in front of this y is actually -1. You multiply the coefficients, you add exponents. What's 2 times -1? -2. And then I'm going to add my exponents. 3 plus 4 is 7. Beautiful. Beautiful. Now we're going to the power rule. Power, right? I think of Wonder Woman when I think of power rule. Power rule. This is when you multiply exponents. How do I tell the difference? The parentheses. When you see an expression, exponents, I can't talk and spell at the same time. When you see parentheses, that means that I have 2 sets of these, 4 sets of these, right? You have to multiply the exponents. Now, what do I do if there's no exponent shown? Like here, there's no exponent. So what do? I'm going to put 1s. And I have a 1 for the, that should be a positive 1. Let me get my eraser. It made a little dash. I don't want anybody confused. I'm going to put a 1 here. And I'm going to put a 1 here, right? And I'm going to multiply. So 2 times 1 and 2 times 1. So that should be -4 to the second power and x to the second power. What is -4 times -4? 16 x squared. And that's it. Whee! What are you confused about, Savannah? Whenever you have parentheses, you have to multiply exponents. If you have a term that does not have an exponent, you're going to put a 1. So the -4, I put an exponent of 1. 2 times 1 is 2, right? And x has an exponent of 1. 2 times 1. Mm-hmm. Because what's 4 times 4?
Where's the other 4?
X right here. That's what an exponent is, right? An exponent means to take -4 times -4, right? You good now? Okay.
Sorry.
No, you're fine. If I didn't have my cup of coffee in the morning trying to do all this math, I've been up since 5 though, so I'm all woken up. Okay, over here. What? Somebody walk me through this. Who wants to walk me through it? I'll let Boy, because you've been walking me through. Okay, go ahead, Boy. Tell me what to do. You can do it. So what's my first step here? What do I have to insert? 1s for the exponent. So 1 goes here, 1 goes here. Do I have to put a 1 here? No, because it has the 2 already. What do I do with 4 and 1? So you multiply each of these exponents, right? Okay. 4 times 1 is what? 4. And 1 times 4 is 4. And 2 times 4 is 8. Excellent. I'm almost done, but I have to give this a number because 2 to the 4th power is actually a number, right? Now, I've asked you all to use this online graphing calculator so you get used to it. What is it, 84calc.com. How come you're not looking for it? Come on. I think that's what it is. Oh, slow. Look at how slow that internet is. I hate slow internet. I know. Look at how slow that is. Come on. Maybe if I just, oh, so, okay, TI 84 online calculator. I don't know why it didn't do it. I had the exact same thing. Didn't I have TI 84 calc?
It's just being weird for some reason.
Okay. Remember I said go ahead and pull this up on your phone so I don't have to run around and pass out calculators every day. And this is the one you want to use because this will look like the calculator you'll use on your test. So if I want to do 2 to the 4th power, how do I do that on these calculators? 2, you use this caret key right here. Caret key, 4. And I believe 2 times 2 is 4 times 2, I believe it's 16, right? So you should get 16. So this would equal 16x to the 4th, y to the 8th. Dun, dun, dun. Can we do power rule? Is everybody good with power rule and know the difference between product, no parentheses, power, parentheses, product rule, add exponents, power rule, multiply exponents, right? Okay. Now,
Product rule add.
I have it written right here. Choo, choo, choo.
I have it wrote down.
Okay, so we have to simplify this fraction. When we're simplifying fractions, what do I do with the exponents when it's fractions? You subtract the exponents, right?
Yes, we were
You're fine.
teaching each other.
That's good. Now, if any time you have a variable with the exact same exponent over each other, that's just 1. Do you all agree that, like, if I have 5 over 5, that's a 1? And if I have x over x, that's also a 1. And let's say I have x to the 5th over x to the 5th. Is that still 1? Yes. So over here I'm looking. What do you notice about m to the 2nd power and m to the 2nd power? What's that going to be? 1. So these cancel out to 1s. And 1 times n squared is just n squared. 1 times 3 is 3. And that's it. That's all you had to do for that one. Now, here though, I have a number in front, 4 divided by 2. What is 4 divided by 2? 2. And is that 2 going to go in the top or is it going to go in the bottom? In the top. Why is it in the top? 4 is bigger and it's in the top. If 4 was in the bottom, then 2 would be in the bottom if it was flipped around. 2 over 4 is 1/2. 4 over 2 is 2, right? Because 2 over 4, you divide both those by 2 to simplify to a half. 4 divided by 2 is 2. Okay, so this cancels out to just a 2, right? Okay, now, when these aren't exactly the same, and it's division, what do I do with the exponents? You subtract the exponents. And where do I put the leftovers? Wherever the bigger exponent originally was. So see here how I have the 2 and it's bigger? So that, yes, the leftover is going to go on the bottom for this one. So what's 2 minus 1? 1. So x is going to go here. And over here, well, x to the 0 is just 1, right? Anything to the 0 power is 1. So I could just cancel that out right away and just put y2. Or you could say 2 minus 0 is still 2, and the bigger is on the bottom, so it stays on the bottom. Either way works. Are we good? It's a review. This is all review. We're going to review again today, right? Okay. So now number 11. So we have a combination here. We have two product rules that are going to be multiplying together, right? So we will do product or power rule, and then you're going to do product because you always do exponents first according to the order of operations. Tundas, please excuse my dear Aunt Sally. Okay, so right here, I have an exponent of 2. What do I do on the inside? Who would like to walk me through this? Rebecca, I know you want to do this. Do you want to do it? Yay! Okay. I surprised her when I said her name, but okay. So what am I going to put with this 1 since there's no exponent? 1. Good. And now what do I do? Okay. So tell me what to write. What about y? Do I need to make it bigger? That better? And then what do I do over here? Mm-hmm. So 2 to the 4th power and y to the 4th power. Good. Now, what do I do next? So 2 plus 4. So the 2 times 2 times 2 times 2 is 16. You usually put that number in the front there. Correct. When you have a negative exponent, we can't write it simplified with negative exponents. Negative exponent means inverse of. If it's in the numerator, you have to push it down to the denominator. If it's in the denominator, you have to push it up. So this would be 16. Beautiful. Beautiful. Yes. 2 right here. 2 times 2 times 2 times 2. See, Savannah, you are not the only one. Didn't you ask that question earlier? Yeah. See? Yep. Okay. We good? We all know where all these numbers came from? Okay. Okay, who wants to walk through number 12? Let's see, who haven't I heard from? Want to do number 12? Okay.
X squared, y squared, x power 8,
Yeah, all right.
and y power negative 8, x 10 power 10, multiply power negative 6. Now x down and y down, x up.
Yes, very good. Okay, I'm going to explain because she went really fast. She's really good at math. Okay, so power rule first, right? That's what she told me. Power rule means you multiply by this exponent. That's where the eighths came from. 4 times 2 is 8. 4 times 2, -8. This she just brought straight down. Now you add the exponents of the like variables. 2 plus 8 is 10. 2 plus -8, -6. I cannot write exponents and leave negatives because it's in the numerator. Remember, negative exponent means inverse of or reciprocal. It does not mean positive, negative in this case. So then you push to the bottom and you get x to the 10th, y to the 6th. And that's the correct answer. Okay. Would someone like to do number 13? Anybody? Want to do this one, RJ?
Sure.
Okay.
So,
Can I reduce the numbers? Do they have any factors in common? No. 4 can only be divided by 1 and 4, 2 and 2. 3 can only be divided by 1 and 3. So you're just going to leave 4 and 3. There's no common factor. I can't reduce it.
so then we can go forward.
Now we can go for it.
It's going to be -1. So can we go ahead and put it on the bottom and make it positive?
Well, you wouldn't. I would push this up to make it positive, right?
Right.
So I would write it as x squared, x to the third. Go ahead and combine them when they are on the same level.
Okay.
Because this is a negative exponent, you can push it up to make it positive. And what's 2 plus 3? 5. So that would be 4. 4/3 x to the 5th. Because this is negative.
So you need to do the inverse first before you solve
Okay,
the
you
problem?
can subtract if you want to, but you better be good at your positive and negatives, and most of you are not. I'll be honest, right? Is that fair? Oh, yeah, I mean, I just grade everybody's papers, and most of you are not. If you took 2 minus -3, right? Isn't this a positive 5?
5.
That's positive 5. Positive would mean I'd be up on top. So either you could have subtracted, but when you subtract, you had a double negative. But I know most of you are horrible with that, so I just tell you get them on the same level so that way you're just adding them together before you simplify. Right? Because if they're on the same level, then you don't have to worry about positive and negative numbers. Okay, so we're done with the x's. Anybody still confused on the x's? I just pushed it up, and then you add 2 plus 3 to get 5. Or you could subtract, but 2 minus -3 is a positive 5, which means it would be up on top. Okay, So now we're done with the x's. We did the 4 and the 3. We're working with the y's now. And this is y to the first power. So when you subtract, am I going to put the y's on top or on the bottom, RJ? Top, right? Because there's more of them up on top than there is on bottom. What's 4 minus 1? 3. So that'd be y to the third. And the reason why that works, if you had y to the fourth, that's 4 y's multiplied together. Down here you have 1 y. Well, these cancel to 1. So that's why you have 3 y's left up on top of multiplying. Okay? This one's the same way where we had negative, but then we have positive. It's easier to combine them when they're on the same level. Okay? Get them on the same level. First of all, 6 and 4, can that be a reduced fraction? 3 over 2. Because both these numbers can be divided by 2. Now, if you didn't know that, you could use your handy dandy calculator. 6 divided by 4. I get a decimal, but if I go math, enter, it changes it to 3 over 2. Right? Okay, now, combine when they're on the same level, right? This x, this means inverse, so I'm going to head up. So I'm going to put x to the third, x to the second. I'm moving this x up. But what do I do with the y? This one's going to be moved down. So I'm going to have y down here and a y to the third. Now, and I can put a 1 with this one. Now you can add, combine your exponents here. So add your 3 and 2. What's 3 plus 2? 5. What's 3 plus 1? 4. And there you go. Okay. I'm giving you time to process it. Do you have any questions on number 14 before I move on? We reduce the fraction. We put the variables on the same level. So this negative exponent, I pushed it to the top to make it positive. This negative exponent, I pushed it to the bottom to make it positive. Now I can use the product rule and just add my exponents. And that simplifies it. Right? Okay. Let's try this one. Let's get things on the same level first when we have these big fractions to make my life easier. I don't have to worry about the 4. There's no other numbers. So 4 stays put, right? What about the m? What am I going to do? Am I going to move an m? Yeah, this one gets moved down. So I'm going to have m to the second, but then I'm going to have an m to the fourth. What about n's? This n stays here, and this one has to be moved up, just like an elevator. Now I can combine 4 and what's 3 plus 1? 4. M, what's 4 plus 2? Dun, dun, dun. Okay, we are going to do Math 360. So I have 1, 2, 3, 4, 5, 6, 7, 8, and I could do 9. I could do 9 groups at boards. We have 19 people here, which would be probably what, 5 groups of, no, 6 groups of 2? No, 14, 6. I don't know why I'm struggling. So I'm going to have 8 groups of 2 and 1 group of 3, right? 2, 4, 6, 8. Oh, that'll work. Okay, so I'm going. Hannah, do you want to just do the worksheet with Mr. Brandon?
Yeah.
Is he here today? Do you know?
Yeah, he here. I seen him in the hallway.
Do you want to work with Mr. Brandon? Okay, let's see if he's available. I'll have to text him to see if he's available. Or you two could work at a table with just a whiteboard if you'd want. And then I will like if I could get you here, I could work with you two, and then I can.
Okay.
If that makes
Can
sense.
I take myself out?
Yeah, I can give you the worksheet.
I just want to try to catch up.
So, because it will get noisy in here.
That's fine.
So if you want to go to the break room, I'll just give you a copy of it. You don't want geometry though.
No, I don't. We don't.
No, I grabbed the wrong folder.
With the power rule, if one of the exponents is a negative, would it stay a negative? So
Well, you
there's
can.
a negative 1 inside the parentheses, but there's a positive 4 outside.
Here, can you read the problem to me?
Yeah. It's parenthesis 4x negative 1 power parenthesis 4.
Oh, parentheses.
Positive 4 on the
For the
exponent.
exponent. Okay.
So
So
that
put a 1 here,
Mm-hmm.
and that'd be 4.
Which I got 4 to the 4th power.
And
X.
x,
Would that
that'd
be
be negative.
negative 4?
And then you can't write it as an answer as negative 4.
Right.
So you're going to push this down, and 4 to the 4th power is what, 64 over x to the 4th.
Thank you.
Does that make sense?
Yes, ma'am.
Okay, good. Okay, now yours is, I have to apologize now so you know what's happening. So your paper that I'm going to give you for the Math 360 is going to be a little different than what I put up here. The only reason is they changed out my computers and I lost the file, so I had to make a new one really fast this morning. Because the one I had was in PDF, and so then I couldn't do a presentation of it. I didn't realize when I saved it to my online file, you know, my cloud file, I saved it as a PDF. So, you know, that's just the way life is sometimes. So, however, I do like my new computer. It's a bigger screen. So, let me see if I can find Mr. Could you get the basket that's crocheted and green? And then there should be a box of markers somewhere there. Or over here. Where are my box of markers? Is that markers?
Oh, yeah, but it ain't for the class. Yeah.
Oh, it's not in there now. Oh, there's a box of markers right there. Okay. Find someone who you want to work with, and you can erase that board. And then once I get everything situated, I'm going to contact Mr. Green. So who are you working with? You gonna work together? Okay. You two gonna work together? Okay, get one mark. Meanwhile, you've done this before in my class, right? You're right. So you need to explain it, because I don't think she's ever done it. Debbie, you've done this in my class many times. So you're gonna explain how to do this. Who's gonna work together? And if it's a yucky marker, I do three want to work together. Okay, doesn't matter. You guys can fight over it. Not all four. Three. Do you feel comfortable, or is there someone else you'd like to work with? Okay. So how this works is I don't think we need to work on that. Because otherwise, it presents a problem. One person has the marker. The other two people are watching and making sure they do it correctly. And if that person doesn't know how to do it, they turn around and say, "Help me," and you tell them how to help them. Okay. Then when you think it's done, I either do this. You say, "Teacher," and I go look at it, and I'll go like this. And if it's good, it's good. If I do this, then you gotta relook at the problem and figure out your mistake. Got it? Yes. And then you change the marker. That's why you only get one marker, because then someone else has to write it. You always take turns. Okay? Unless they do. Yeah. But if you don't have an IEP, and this is Mr. Adams, so don't blame me. Yes, here he did, but it was him who said no more. He wanted just, yes. So if you're gonna yell at someone, you go up there and you yell at him or yell at me. But he said he wanted, the reason is because he teaches the credit recovery, or the credit. You can't use anything. So he wanted us to start weaning people off the notes. So you're allowed one page that you create. I'll give you one page to write your formulas and notes up. Now, yeah, yes. So just talk with him, and you can research all that information. And because you told me, I'll go ahead and let you know. And if Mr. Adams has a problem with that, then you can yell at him.
I lost my algebra 1B notes yesterday. I don't know how. I filled it out and spent the time.
Do you want a new one?
Yes, please. Y'all got this. Thank you.
Okay, there you go. Yes. Okay, so, back to your boards, find your space. You can erase what's already on the board. 2 groups at each one. Yes. And I gotta get. Go to the board. I'm gonna put the problem up in a minute here.